All right, good afternoon, everybody, and welcome. Thank you for joining us for this, our second in a series of 2021 webinars. Our last webinar, if you joined us about a month or so ago, was on microsurfacing and cape seals, top of the curve preventive maintenance treatments intended to keep good roads in good condition. And today we're going to go way down the curve to the bottom half of the curve and talk about a treatment to fix bad roads, and that's cold in place recycling. Before we jump in, let's take a look at our poll results. Interesting. So it looks like the majority of our audience, about almost 70%, are road owner agency people, about half of those being local agencies. And then we've got another 15% or so each in engineering firms and contractor suppliers. So a real diverse audience. Great to have you all with us here today. And let's get started. So we have a lot to cover here today. Let me take you quickly through our planned agenda. I'd like to start off by giving everybody sort of a 30,000-foot high-level overview of the basics of the process, so we all have an understanding of what cold-in-place recycling it is. Then we'll have the first of our two guest speakers, Keegan from Kimley-Horn Associates, come in and talk about what roads are appropriate candidates for the CIR process. Then my colleague, Teto, our QC manager here at Indus, will be talking about the mix design process that we employ on every project. Then I'll quickly go step by step through what we do to build a job, the construction sequencing. Then we'll talk about what Matt and the crew supervisors and crew members do to ensure high quality workmanship on cold in place recycling projects. Then we'll have our second guest speaker today, elected highway supervisor or surveyor Scott Crisafulli from the town of Milford, Massachusetts, be joined by my Indus colleague Alan Vial to share Scott's experience. He's done 2 CIR jobs thus far, and he'll share his experience on those projects with us. Then I will close by talking about some of the reasons why more and more agencies are turning to cold in place recycling to fix their bad roads. And then at the end, we'll take whatever time you'd like to answer as many questions as we can. So a lot to cover, and let's get started. No secret or surprise here. We all know we have a lot of bad roads in this country. I guess it was a little surprised by this $600 a year statistic, but a lot of that has to do with accelerated depreciation on our vehicles, driving them over such rough roads. And lots of talk in Washington right now. If anybody saw the president address Congress last night, a lot of talk about spending lots and lots of money on fixing roads and bridges. So that's a real positive. Looking forward to seeing how that ultimately shakes out. You know, there's lots and lots of disagreement on what infrastructure is, the definition of infrastructure, but there's bipartisan agreement that we need to do something to fix our bad roads. The thing to keep in mind, though, is that no matter how much money ultimately trickles down from Washington to the states and hopefully to the local levels as well, there'll never be enough to fix all our bad roads. So it's still going to be incumbent upon us to spend that money as wisely as we can. And that's where I think CIR can play a role in some communities. Some people have accused me sometimes of being a little too wordy, and I plead guilty to that. I probably talk too much, but when I was thinking of the most succinct definition I could come up with for cold in place recycling, it's here on the right-hand side. Plain and simply, it's a sustainable option for your bad roads. And sustainable has a lot of different meanings, and we'll get a little more into that later on. So an unfortunate fact of life in our business is that no matter how good a job we do building or rebuilding roads, right off the bat, they start sliding down this deterioration curve. And if we miss opportunities to intervene doing preventive maintenance, some of those treatments that you see in the top half of this curve, then we're forced to do rehabilitation. Much more expensive and intensive processes down on the bottom half of the curve. And again, when I look to describe what is cold in place recycling, to me, it's for roads that are a little too far gone for a shallow mill and fill, but not gone far enough to warrant full depth reclamation, or to have distresses that show an inadequate subgrade or subbase. So it's this portion of the curve, sort of a tweener treatment, if you will, between mill and overlay or shim and overlay, and full depth reclamation. And here's a good picture of what I consider a good CIR candidate from our friends at Environmental Partners Group, the asset management folks there. You can see heavily distressed, low PCI. I think most people's knee-jerk reaction decision on this road is that has to be FDR. But I think you need to look at the cause of the distresses. Are they age-related distresses, or are they subgrade, sub-base related distresses? I would say, since there's not a lot of rutting in the wheel paths here, that we don't have subgrade and sub-base issues. I think it's mostly age and mix-related issues. So that's a good candidate. Same thing on this photo. Heavily distressed, but if we had subgrade and sub-base issues, I think you'd see a lot more wheel path rutting than we do here. So again, what is cold in place recycling? Well, in its simplest forms, it's millings, or wrap as it's often referred to, that we add stabilizer additives to create a 3 to 5 inch thick intermediate or base layer, all in one continuous operation. So workhorse of the operation is this recycling machine right here, and it looks like a milling machine that you'd see out on a milling and paving job. Couple of key differences. One, we're allowed to, it's set up to inject asphalt into the chamber, which we're going to get into here in a second. And secondly, it's down cutting instead of up cutting. The down cutting allows us to control particle sizes. If we were milling, it would be up cutting because we're looking to get material out as quickly as possible. 2 stabilizer additives go into most of the jobs that we build. The first is Portland cement. Generally, it's dosed at 1% by weight of the wrap. And the second additive is foamed asphalt, PG binder, typically 6422 binder that we use in this region. And most of our mix designs for that come back calling for between 2 and 2.5% new asphalt being injected into the millings. And foamed asphalt, it may be a new term that some of you are not familiar with, but it's certainly not new technology. It was developed in the 50s at Iowa State University. And then the Mobil Oil Corporation, I think in the 60s and 70s, had the patents to it. And for about the last 25 years or so, Workin has had the patents, and they've advanced the technology in the road industry all across the world. And the basics of the foamed asphalt process are shown by this schematic right here. We have 18 of these nozzles spread across the 12-foot 6-inch drum width on our recycler. And that's a nice drum width because we can recycle a full lane width in one pass. So 18 of these nozzles spaced about every 8 or 9 inches across the width of that drum. We inject a hot PG binder, like 325 degrees Fahrenheit or so, a little bit of water, a little bit of compressed air. And when we do that, the asphalt sort of explodes. It foams way up to about 10 or 15 times its original volume. And when it foams up, it grabs the fine particles from the wrap. The Portland cement that we've added ahead of the recycler, it grabs the fine soil particles from the wrap and creates sort of like mortar balls. Think of a mason with a couple of bricks or a couple of blocks and a trowel of mortar, sticking those 2 bricks or blocks together. That's what we're doing with foamed asphalt CIR recycling, is we're creating mortar balls and then sticking the larger wrap particles together. So it's a non-continuous coating, unlike new blacktop coming out of a hot mix asphalt plant or even emulsion stabilized CIR. This is a non-continuous coating, and the advantage to that, as you see, is it slows down the rate of reflective cracking. Reflective cracking is a huge issue that we have to deal with here in the Northeast with all of our freeze-thaw cycles. So that's one of the reasons we chose to go the foamed asphalt route. And at the end of the day, this is what we're producing. This is that 3 to 5 inch thick CIR base or intermediate layer that we're creating with the CIR process. This is actually a sample of material right off the first road that we did, Pond Street, about a half a mile down the road from our office here in Braintree, Massachusetts. And you can see, well-graded material, very durable. The town has subsequently come in and put an 1.5 inch hot mix overlay on that. So we've got over 6 inches of crack-free, distress-free material carrying the traffic on that road right now. So a nice, long-lasting, durable product that we're creating. So we have another poll question we'd like to ask. At last count, we had about 150 registrants for this webinar, and we'd like to get a feel today for what people's experience or which of these different alternatives for rehabilitation they've seen in person. So we could just take a few seconds for you to click the ones that you've actually seen performed in person, and then we'll share the results with the group. You can go ahead and share them, Ryan. Interesting. That's kind of what I would expect. Obviously, I think mill and fill repaving is a treatment that is most prevalent in the rehabilitation sector in this area, and FDR is also very prevalent. So about 75 to 85% of our participants today have seen those. A lot have seen more than I would have expected. Have seen full remove and replacement. I don't see that going on very often, and only about 40 to 45% have seen the hot and cold recycling options. So I'm glad you're all with us here today, so we can share more about CIR, and we'll talk about how you can get out and see a job in progress a little later on. Thank you, Ryan, for those results. So before I turn it over to our first guest speaker, I thought I'd share this chart because I often get asked the question, is hot in place recycling the same as cold in place recycling? And is cold in place recycling kind of the same as FDR? The thing they all have in common is that they're recycling alternatives of existing pavements, but you can see the primary differentiator between the three is the depth of treatment. So we're looking to eliminate distresses and improve the asphalt material quality with each of these processes. The hot in place recycling is typically substituted for shallow mill and fill, so only about 1 or 2 inches deep. The cold in place recycling, as I've said, is an intermediate or base layer, typically 3 to 5 inches deep. FDR much deeper, of course. And another big differentiator is the FDR is the only one of the three that goes down into the underlying granulars and subbase. Neither of the other two do, and all three need some sort of wearing course. So now I'd like to introduce the first of our guest speakers today, Kathy Keegan from Kimley-Horn. I first heard Kathy's name, I think about 5 years ago, when I heard what a great job her and her team were doing, helping the city of Manchester with their pavement management program up there. And then about 2 years ago, I think I heard that Kathy had written her master's degree thesis on the subject of cold in place recycling. So I finally had a chance to meet Kathy in one of our cold in place recycling jobs. I think it was in Bedford last summer. Have grown a great level of respect for her for both her pavement management abilities and knowledge of cold in place recycling. And with that, I'd like to introduce Kathy.
Thank you, Dan. So I'm a little shorter, so I'm going to stand up here. So thanks for allowing me to be part of this today. I've been working with cold in place recycling for about 25 years. First as a road owner. So I had about 3,800 miles of roadway that I was trying to manage, all asphalt. And we were looking at better approach to getting longer life out of it than an overlay was giving us. And so we tried cold in place recycling, and frankly, we never looked back. So I want to start with, I'm going to talk about how to select the right candidates for this type of treatment. If we step back to the life cycle curve that Dan showed, I want to bin it back into some higher level groups, just routine maintenance, preventive maintenance, rehabilitation, and reconstruction. What you can see here is that CIR actually can work very well in major rehabilitation, but also in reconstruction. And so it's really important that we look at more than just PCI. So you can see the condition scale on the left, and PCI is generally used in your pavement management program to select the treatment. But if we look only at PCI, we may miss an opportunity to use CIR. So really our focus is on wanting to apply the right treatment on the right pavement at the right time. That's our focus. So when we're making this treatment selection, we want to think about more than PCI. So we want to look at the surface condition and say, what is it telling us about the underlying conditions? And then we want to look at comparative treatments and say, well, what will each of them fix? Also, we want to finally think about rehab constraints. So do you have curb reveal issues, for example? So let's start with the treatment selection piece and what we see on the surface. So you can see I've put groupings of distress types. So we have cracks, which could be just linear, transverse, block. At the bottom are surface distresses, so things like bleeding that might have friction issues or rattling. In the middle, I have structural. So that's our fatigue cracking, so wheel path cracking, as well as rutting. Now, at the top of this chart, you'll see the extent of the problem. So when by extent, I mean how much of the distress is there, and how bad is it? So the coloring shows green for where cold in place recycling can have a high impact. So if we look at cracking and we think about cold in place recycling, just like overlays or mill and overlays, we're actually removing the surface. And so, of course, it's going to have a high impact on getting rid of cracking. If we think about surface distresses, again, we're dealing with the surface. We're going to put a new surface on for you, so it's going to address anything to do with rattling or friction issues. On the structural side of things, if we have localized issues or things that aren't affecting or aren't sub-base issues, cold in place is also a good treatment. The more structural issues we have, the more extensive and the worse they are, cold in place may not be a good solution for. So let's look at what the different alternatives might fix. So if you look on the left, we have just a typical structure of asphalt over top of some kind of an aggregate base and subbase on subgrade. The existing asphalt has cracks. So some of them are top down and some of them are bottom up in full depth. If we place an overlay on, one, we're going to add some grade to it. Okay, so if you have a curb reveal issue, this may be a problem. And we're going to have cracks that reflect up through that overlay. We know that in this climate, we're going to have cracks reflect up at the rate of about 1 inch per year. So in a year to 2 years, you're going to see all those same cracks on the surface. If we did a mill and overlay, so now we don't have a curb reveal issue, we're going to take off some of those cracks, but the full depth cracks will still be there and they'll reflect up again in about a year or two. So a little bit less cracking reflecting through, but still some. If I do cold in place recycling, the objective, as Dan showed you, is to get rid of mostly asphalt. So we're taking 3 to 5 inches off, replacing it with a new layer, and then putting a surface on top of that. If so, cracks are gone, we won't have the reflection through, so we got longer life. We are increasing the grade, but if we wanted to mitigate that, we can actually go in and mill in advance and then come in and recycle so that we end up with the same grade as an output. So knowing that, let's look at some pictures of roads and talk about what the right treatment would be. So although I have a PCI up here, we should be thinking of this independent of that. What do we really see on the pavement? So if we look on the left, I might say that looks like a good overlay candidate. But if I look closer on the right-hand side and on the curb wheel path, I have a lot of potholes and I also have structural cracking. So if I do an overlay, that's going to reflect back through very quickly. So cold in place would actually mitigate that really well and be a better alternative. This is a great candidate for cold in place. I have a very non-homogeneous section, a lot of utility work done, a lot of patching. If I do a mill and overlay, I may not get deep enough to get those cracks. So if I come through with a cold in place, I'm going to get a nice homogeneous surface as a result. This one, I look at and I think, okay, mill and overlay. But then when I look closer, I can actually see that the surface layer is delaminated. And this is probably an overlay just done without any milling. And I've actually got structural cracks underneath it, some alligator cracking. So that's all going to reflect up through. So a better treatment here is to come through again and cold in place. This last picture here showing I've got a lot of fatigue cracking in one of the lanes. And if I look closer, I see rutting in addition to this right along the curb lane. I've probably got garbage trucks going through here, and I've got a road that really just wasn't designed for the traffic that it's seeing. And this issue is subgrade or subbase related. I can't fix this with cold in place, so I'm going to look at another alternative if I want like a multi-year solution on this. The last thing I wanted to talk about was how to integrate the cold in place with the utility work. So this is a real project, and on the left side you can see that the utility trench was done, and we have repaving. And the design was to actually put a shallow mill and fill here. Now that was likely done by the utility folks. So the sewer or water folks said, just grab standards back and gave to the contractor and said, this is what we should do. If you gave this to the highway or the road engineer, they would look at this and say, well, a mill and fill, shallow mill and fill, that's going to last not very long at all. We actually have a really good CIR candidate. So I think the message here is to get, folks on the same page about what the right treatments are, so you end up with longer term solution. So now, once you've decided on your candidate, you have to make sure that you design it right, because you won't get longevity in construction if you don't do that. So you have to know how thick the pavement is, how much you need to recycle, and what the additive is, how much foam asphalt you need to put in. And so I'm going to hand this over to Matt Teto now, who is the indus lead on QA/QC, who knows all about mixed designs, and will walk you through that process.
Thank you, Kathy. Every CIR project begins with a thorough coring of the roadway at 500-foot intervals, sometimes less. We take 3 cores, one near the center line and one within about 3 feet of each shoulder. And that gives us some insight into the composition and condition of the existing pavement surface. You can see here by our example coring log. We also note, whatever we may find for subbase and anything that we may find within the pavement itself, such as membrane or fabric. So once we've got those cores, they get packaged at our shop and shipped to American Engineering and Testing in Minnesota. And there they're trimmed to proposed CIR depth, frozen, and crushed in a laboratory crusher. So this material is then screened and reproportioned to simulate material gradation that's being produced by the milling machine. I don't know if Ryan's in. I need a slide advance. There we go. There's some pictures of the wet saw and the laboratory crusher from our design lab in Minnesota. Go ahead and go to the next one if you would. So there's the picture of the screen and the screen material. We break that down into size fractions and recombine it. That gives us some consistency amongst the samples that they're going to fabricate later. In addition to the cores, we also send them about 10 gallons or so of our liquid asphalt. And that is then blended in the work and lab foamer. This is identical in design to those nozzles that Dan showed you earlier. And so that, being identical in design to that, what's on the milling machine, we know we can expect the same expansion ratio and half-life in the field as what we got in the lab. Next, we'll mix that recycled material, the foamed asphalt, with our mineral filler. And we'll mix it in a pug mill. Working's got a really nice pug mill mixer for the lab. And the pug mill design ensures thorough mixing with less material segregation and less material breakdown that you may find in a standard bucket mixer or stand-up lab mixer. So that material is then mixed at 3 different asphalt contents. And from that, we fabricate 6-inch diameter samples. Those are compacted in the super paved gyratory compactor to 30 gyrations. Once they're cured, I measure the density, and then the samples are conditioned for testing. So to determine our optimum asphalt content, the samples are tested for indirect tensile strength in both dry and saturated conditions. In addition to that, we run a Marshall stability test. It's not typically required by spec, but we do it to confirm our optimum AC and make sure we haven't introduced any stability issues due to over asphalting in the mix. So that was a very quick high-level overview of our mix design process. Just would like to thank the fine folks at American Engineering and Testing for the lab photos that they provided for us.
Thank you, Matt, and thank you, Kathy. Sorry, Matt, for the little slowness on the slide advance there. You guys are both true professionals in this industry, and I appreciated you joining us here today for our webinar. Now that we've talked about both candidate selection and the mix design process, let's have some fun and look at how we build these things in the field. So the first thing we do, actually, before any of the equipment or the recycling crew shows up, is we drop and plate all the manholes, catch basins, water valves, gas valves to get them down below whatever recycle depth we're shooting for. And then when the recycling crew mobilizes to the job, generally the first thing they do is pre-mill the road. And I say here, if required, if the height is constrained on the finished product, and usually we're putting an 1.5 inch hot mix overlay on top of the cold in place recycling, and we don't want to lose curb reveal, or we don't want to have issues with adjacent driveways or side streets, then we have to remove enough material to make room for that 1.5 inch overlay. So we do this pre-milling, simply making space for the overlay. After pre-milling, we dry spread the Portland cement ahead of the recycler with this calibrated truck. Generally, as I said earlier, it goes in at about a 1% rate by weight of the wrap, and that works out to about a pound of Portland per square yard of pavement per inch of recycled depth. But then along comes the recycler machine, and you can see on the left-hand edge of this photo, you can see that Portland cement that was dropped on the road ahead of it. The recycler, we're injecting a little bit of water in for the foaming of the asphalt and for the compaction of the mix. We're injecting the new PG binder in. We've got 18 of those foamed asphalt nozzles spread across the width of that cutter housing. We're cutting 3 to 5 inches deep, blending in the Portland and the foamed asphalt, and conveying that newly reconstituted mix back to the conveyor on the paver that you see on the right-hand edge of the photo. And then we lay it down just like a normal paving job. The paver has a very, very heavy screed, as you might imagine, because of the 3 to 5 inch layer thickness that we're paving. And when you first see these mixes, they almost look dry because, again, they are not 100% encapsulated like you would see with a new blacktop paving coming out of a blacktop plant. We've got that mortar ball or spot welding adhesion of the wrap particles. So the mix looks a little dry, but there's plenty of asphalt in it. And then right behind the paver, we've got two big rollers. The roller on the left, I think, is a 14-ton double drum vibratory roller. That's the breakdown roller. He's right behind the screed of the paver. And then behind him is the finish roller. It's a unique pneumatic roller by Sakai that in full vibe mode is a 27-ton static equivalent. So compaction, very, very important. And Matt will talk more about that here in a bit. And there's an overhead view of the whole train. On the right-hand side, the first truck in the series is the water truck. The second truck is the PG binder tanker. Then you've got the recycler and the paver. And from the front bumper on the water truck back to the screed on the paver, it's about 150 foot long overall. Once we have achieved the target densities and with compaction, and before we leave for the day, we always fog seal whatever was recycled that day. The fog seal serves two purposes. One thing that it does is it seals up the mix from water intrusion until the wearing course gets applied. And the other thing it does is it keeps the fines in the mix from being trafficked out by traffic when it's reopened. Then within a few days after the recycling is completed, we come back and readjust all those utilities that have been dropped down below the recycled depth, bring them back up to the finished paving grade, fill in around them with new hot mix binder. And then we put a wearing course on. For this particular job, the community chose about an 1 inch to 1.5 inch hot mix overlay. The nice thing about the CRR process, one of the things I really like about it, is you can use a wide variety of wearing course options. I would say somewhere between 80 and 85% of the projects we do get some sort of hot mix asphalt overlay, anywhere from 1 inch to 2 inches. I think we've done 6 or 8 projects where the community chose microsurfacing as the wearing course. In fact, the first project we did, the Pond Street job I mentioned earlier here in Braintree, this was the microsurfacing done on that job. High volume roadway. I think they told us it was about a 20,000 AADT with about 10% trucks. They didn't have the money to do an 1.5 inch overlay, so they said, we're going to roll the dice and try microsurfacing on top. And that's what it looked like a year or 2 after we did it. Performed very, very well. And since then, they've had the money to come in and add the 1.5 inch overlay. Other options include chip seals, cape seals, which are a chip seal followed by microsurfacing, or another option that we're investigating right now is what's called cold central plant recycling. And that's where we take stockpiled wrap and add some asphaltic materials, some rejuvenators, and then truck those back out and pave them on the job so that we could actually have 2 layers of recycled material, a cold in place recycled intermediate or base layer, and then the cold central plant recycled wearing course on top. So now I'd like to bring Matt back in to quickly talk about some of the quality control considerations he and the crew pay attention to when we're building these jobs.
Thank you, Dan. So in some ways, the field QC for CIR is similar to QC for paving. We want the right weather conditions, the right kind and size of equipment, well-maintained equipment for the job. And we want to ensure we're using the proper materials and in the amounts specified by the mix design. So where this differs is primarily in the compaction process, as well as some aspects of inspection and process adjustment that we'll touch on. So, field CIR quality control is similar to HMA paving, except when it's not. So with CIR, there's a few additional things to check at startup, and they all start with the milling machine. Could you advance the slide, Ryan? There we go. You'll want to sample the foamed asphalt at the port of the machine to confirm expansion ratio and half-life. You also want to take some time to check your milling depth and profile, since what we're taking up is going right back down with no, there's no corrections after the fact. And we want to check the maximum particle size of the mixture. So in this photo, you see Paul just doing a quick shakedown to make sure we've got the right aggregate size. Once the paver's off the starting blocks, it's important to do your basic paving inspection. You want to check your thickness and cross slope of your mat, check that your joints are well formed and compacted, and check to make sure the material is consistent across the mat. Are there pockets of oversized material? Because correcting in the beginning will save you headaches down the road. So after the paver's put out some material, it's time to get to work determining target density, and this is probably the biggest difference between CIR and HMA paving. So we'll select 3 random locations in the first 500 feet of paving. We'll measure density with the nuclear gauge after every roller pass. And when those readings have leveled off, we'll consider that we've reached our maximum. We'll have the roller move up the road, and then we'll measure the density at an additional 7 random locations within that first 500 feet. And then the average of those 10 readings, that will be our density target for the day. So some minor adjustments might be necessary throughout the day. Changes in weather conditions, such as increased sun or wind, that may require you to add more compaction water, and it's things that you'd not typically see in paving. The sudden appearance of large particles in the mix might require adjustments to your milling depth or your milling speed, and sometimes a change in the existing material is just significant enough to require a new control strip. It's not common, but it does happen. If the technician gets 3 consecutive density readings that are less than 90% of his target, or greater than 105% of his target, a new test strip is warranted. So we'll take out another 500 feet, repeat our density measurements, and then we'll go with our new density target for the day.
Thank you, Matt, and really thank you and the entire crew for the commitment you've made towards ensuring our clients get the highest possible quality with this cold in place recycling process. We appreciate everybody's efforts on that behalf. Next up, I'd like to introduce our second guest speaker today. It's one of our clients, Scott Crisafulli, the highway surveyor from the town of Milford, and he's going to be joined by my indus colleague, Alan Vial, and Alan's going to talk with Scott about Scott's experience doing 2 cold in place recycling jobs thus far. Alan and Scott?
Well, Scott, thanks for joining us today.
Thank you, Alan.
Your first project was Route 109 Medway Road. As I remember it, it was about 3/4 of a mile long and probably about 48 feet wide. What made you choose cold in place for this process?
So, yes, Medway Road is 4 lanes wide. We had a very decent thick layer of hot top, 6 to 7 inches.
Right.
We had a lot of cracking, large cracks, wide cracks, but the sub base overall was pretty solid. There was no misshaping of the road. There was no rutting. So to go in there and try to take that whole road up, FDR or and to make that mess and to disturb the base, which was pretty solid, was just way too expensive.
Okay.
So cost savings with doing the CIR was absolutely the way to do it, and to be able to recycle that 7 inches of hot top, put it back down. We did put a 1.5 inch overlay over it, so looked like a new road.
Excellent. It seems you're very pleased with the process. Was there any one thing that really stuck out to you about what made the success of this?
Well, the process in general, very, very quick. The traffic flow was easy to deal with.
Okay.
It wasn't messy, and we didn't deal with dust and dirt roads and hauling materials in and out. And again, it's recycling, which is what we're trying to do as much as we can. So yeah, pretty much very, very fast process.
Excellent. I looked at that road with you many times, and I would agree with you that your only other option there would have been an FDR. Do you feel you're getting the same performance as you would have got from the FDR?
Yeah, I mean, so far it looks like that's what we did. We were concerned with our curb reveals and our driveway approaches, and there was no grading involved.
Gotcha.
Everything went right back to the way it was. We did mill out some of the material to keep the grade down, but yeah, it's just the same thing. It looks exactly
Excellent.
the same.
Well, then last year you did your second CIR project, which was Route 85, Cedar Street. Went from the Hopkinton town line right up just short of 495. How's that compared to the first project you did? What were the similarities? What were the differences?
Again, another highly traveled road. Rush hours are bumper to bumper. The traffic flowed. That was one of the things I noticed right away. It was, we didn't hold anybody up, we get no complaints about it. But as far as the actual cold in place product, it's exactly the same. Again, we did an 1.5 inch overlay, and it looks like we went in there and did full depth reclamation, but same results. Exactly.
Excellent. Actually, for those watching, that section we did last year is my background. It's very proud of that picture. This year, Scott, we're looking at another section of Route 85. Basically, we're going to jump over 495 and head towards the center of town. It appears you're concentrating your CIRs on your main arterials. Is that where you see you're going to get the most benefit from this process?
Well, so far, we have got the most benefit because of the traffic control and the overall easiness of the process, I guess I want to say. We are looking, maybe next year we want to do some residential areas. Trying to figure out which would be the best candidate for it. So in the future, we definitely want to expand on this process and use as much as we can.
Excellent. Well, Scott, thanks for joining us and being part of this webinar. And for anyone that's interested, we're going to be in Milford sometime in June. Feel free to reach out to Dan, myself, or any of the other regional managers, and we'll be sure to get you the specific dates. Will be there. Dan, back to you.
Thanks a lot, guys. A great job. It's always good to hear about these processes from the client's perspective. And I'm glad to hear, Scott, that you're happy with the process and glad that you added it to Milford's pavement management toolbox. Just for our attendees' benefit, here's a picture of the two roads that Scott has done with CIR. The one on the left is Medway Road. It's the first one he did back in 2018. And I took this picture before the wearing course was applied. Scott just mentioned that he chose to do an 1.5 inch hot mix overlay on the road. And I was there right after we got done recycling, and I was so impressed with the pavement markings Scott and his crew put down on the road. And I hadn't seen that on any of our CIR jobs thus far before the wearing course. I had to get a picture. That's it. And you can see, of course, why he did put the pavement markings down. Very, very busy 4-lane commercial corridor. And then the one on the right is Cedar Street, the first segment that we did last year. And then this year, as Alan mentioned, we're going to be doing a second segment. So thank you again, guys. Appreciate you joining us today. So in closing our webinar here today, before we get into your questions, and I see we got quite a few questions in the chat box, so we're looking forward to addressing those. Let's talk about some of the reasons why more and more communities are adding cold in place recycling to their pavement management programs. And in one word, I think that the reason why they're doing that is sustainability. Sustainability is more than just about environmental, although we generally think of environmental benefits when we think of the word sustainability. But the true triple bottom line of sustainability also includes societal and financial benefits. And just to explain that a little bit, if somebody invented a car that got, say, 100 miles to the gallon fuel economy, but the car cost $100,000 to buy and only fit one occupant, it would check the environmental box of sustainability, but it wouldn't check the societal and financial boxes of sustainability. So when we talk about the triple bottom line, we're talking about the intersection of those three circles right in the middle. And we want to check all three boxes, which cold in place recycling does. So let's start first with the environmental box. Since Earth Day was last week, a big benefit is by recycling 100% of the existing materials on the road, the aggregates and the asphalt cement that have been drilled from petroleum resources. Those are finite resources, right? We're not seeing a lot of stone quarries being permitted today. We should all be doing our best to try to make those finite resources last as long as they can. CIR reuses existing resources. And by reducing a lot of the trucking and heating of materials, we save a tremendous amount of energy with the CIR process. And of course, greenhouse gas emissions. There was a lot of talk in the last week or so from both President Biden and Governor Baker here in Massachusetts, making commitments to reduce greenhouse gas emissions. And CIR does a lot as it relates to reducing greenhouse gas emissions. There's a very handy and cool interactive calculator on the industry website, roadresource.org, that you see referenced down there at the bottom of this slide. And what it allows you to do is to compare the greenhouse gas emissions of two treatments side by side. So for this example here that I'm showing a screenshot of, I took a major mill and fill, and that's defined as a 3-inch deep mill and fill on a 30,000 square yard project. And I compared it side by side with cold in place recycling with an 1.5 inch hot mix asphalt overlay. And you can see not only did the CIR option save not quite 10% of project cost, but more importantly, it reduced greenhouse gas emissions by 38%. And that's the equivalent of taking 24 cars off the US roads for a year. So a really cool calculator. I would encourage you to go to the roadresource.org website, check it out. I believe it's called a sustainability calculator. Moving on to the societal benefits of CIR, also a lot of talk recently about looking for shovel-ready projects. Lots of debate in Washington now over bringing stimulus funds into the economy, specifically targeted at improving our infrastructure, including our roads and bridges. So we know our elected officials are going to be looking for shovel-ready projects. The nice thing about CIR is if you have a bid in place, it only takes about a month to do that coring and mix design process that Kathy and Matt talked about earlier. So very much shovel ready. If your community wants to get ready for these stimulus funds that hopefully flow down from Washington soon, you might want to be looking at CIR candidates so you can be shovel ready to do those jobs. And it's a long-lasting treatment. You know, we've talked about that kind of throughout our webinar. Unlike an 1.5 inch deep mill and fill or a 2-inch deep mill and fill, this has the longevity similar to your full depth reclamation treatment. You know, we're always, you know, we're kind of fanatics about roads, so we can't help ourselves from taking pictures of roads when we drive around all the time. And the photo on the left was taken back in September 17, so just 3.5 years ago. It was in a community north of Boston, and the person that took the photo sent it to me and said, "Wow, I can't believe they're just doing an 1.5 inch mill and fill on this road." So I went back this past weekend and I found the exact same location. I took the picture on the right. So that's basically 3.5 years later, most of those cracks have reflected through. So we talk often about right treatment, right road at the right time. I don't know what influenced the town to pick that treatment, but I think we'd all agree it probably wasn't the best value for the taxpayers. So CIR is a much longer lasting solution. Kathy talked about jobs like this. This is a job also north of Boston in Massachusetts where the designers specified a thin mill and fill overlay as the pavement restoration on this road after some utility work was completed. So I hate to see money spent like that. We all know that in 2, 3, 4 years, most of these distresses are going to be reflecting up through, and then we'll have to spend additional money on that pavement. So we're looking with CIR, building a 3 to 5 inch intermediate layer, and then putting another wearing course on top of that. Much longer lasting than shallow mill and fills. And we all know how impatient the public is nowadays. You know, they want the roads fixed, but nobody wants to be inconvenienced the least bit. So one of the big benefits of CIR is it's way less disruptive than other rehab techniques. This is a busy Route 1A in Revere, north of Boston. And you can see it's a divided 4-lane highway. And we did that project, I think it was last May, and we're easily able to keep traffic moving the whole time. As you look at these different rehabilitation options listed on the bottom here, cold in place recycling, full depth reclamation, and reconstruction, it's pretty clear which one of those processes provides the least disruption to neighboring property owners, neighboring businesses, and the traveling public. Far and away the least disruptive of those major rehabilitation processes. But the number one set of benefits that I think most of our public works friends are concerned with in these times is the economic benefits. You know, nobody has enough money to do everything they'd like to do, so they're looking to stretch their dollars and spend them as wisely as they can. So to answer that question about the economic sustainability of CIR, we need to know how much CIR costs, right? And CIR costs vary tremendously. But I'm going to take you through some of the variables that go into it, and then we'll talk about some ballpark costing. So, of course, you might imagine larger projects cost less per square yard than typically smaller projects do. There's a lot of fixed costs, including mobilizing a lot of equipment and manpower to the job. So the bigger the job gets, those fixed costs get spread over more square yards, and it drives the square yard unit price down. Production capability, it has a huge impact on cost. If we have a long, straight stretch of road with minimal traffic, minimal side roads, then we can achieve a lot more square yards per day than we can in shorter segments of road in, say, urban or suburban locations. So those are more capable of higher production and lesser cost. The utility structures, I showed you earlier that we have to drop and plate and then come back and raise all the utilities after recycling. So the more of those we have, then the higher finish cost of the job and higher unit price per square yard. Road height restrictions. If we have to maintain the existing road height and we want to put an 1.5 inch hot mix overlay on the road, then we need to take material away. That adds a little bit of cost. Depth of recycle is a factor. The range of depths is typically 3 to 5 inches, and since we're adding the stabilizers, the Portland cement and the PG binder as percentages of weight of the wrap, the deeper we go, the more expensive per square yard the process becomes. And then lastly, of course, depending on the wear course selected, from say as little as $3 a square yard for a chip seal up to as much as maybe $10 a square yard for a couple inches of hot mix. Wide range there as well. So when people ask me how much does CIR cost, there's no real stock answer. But if I had to give you one number here today that I think is kind of middle of the road for most jobs, I think it's probably in the range of $20 a square yard. And that includes the wearing course, that includes mix design, that includes the coring, includes the utility structures, everything soup to nuts except for the striping, the pavement markings. And that's kind of a good middle of the road number. If it's a slow production, lots of utilities, the number will get higher. Big production, Less utilities, it'll be a lower number, and probably the range from that $20 middle of the road number, maybe 15%, maybe 20%. So as low as could be $16 a square yard to 24. That gets you in the ballpark, just to give you a feel for how much this process costs. So let's go back to the picture that we showed earlier of the, probably everyone would agree, an inappropriate mill and fill candidate on the left that was done anyways. I'm guessing that back in 2017, the town spent somewhere on the order of $14 a square yard. I'm also guessing that they might get 7 years out of it, and that's a hard thing to guess. Here we are 3.5 years in, the picture on the right, and we can see a lot of that cracking come through. Are we going to get another 3.5 years? For the purpose of this exercise, let's assume that we are. So that works out to an equivalent annualized cost of $2 per square yard per year. So the $14 unit cost to do the shallow mill and fill, 7-year life extension, $2 per year per square yard. That's relatively high when we're looking at equivalent annualized costs, and it's reflective of really the wrong treatment on the wrong road. So now let's look conversely at another community. This would be for the city of Manchester, that about in that same time frame, in the late summer, early fall of 2017. This is East Industrial Park Drive up in Manchester. The stresses that it exhibited back in the summer of 2017, some transverse and longitudinal cracking, and then some areas of fatigue cracking. So it was a good CIR candidate. The middle photo is what that looked like a couple of months after it was paved. And then we were out there yesterday taking another picture. And other than the new HMA surface course being pretty oxidized, which it has a tendency to do over 3.5 years, no distresses reflected back through. Probably just a good fog seal candidate, or maybe a microsurfacing candidate in a couple of years. Just good preventive maintenance to keep that surface in good shape. But that's really the right treatment on the right road at the right time. And let's look at that equivalent annual cost. I think Manchester, all in on that project, spent about $18 a square yard. I think we can all assume it will serve at least for 15 years. So that works out to an equivalent annualized cost of only $1.20 per square yard per year, as compared to the $2 on the inappropriate mill and fill that we looked at earlier. So 40% lower EAC, and it might not sound like much money when you say $1.20, $2, we're just talking about a little pocket change. But when you start multiplying those equivalent annual costs times networks that might have 1 million, 2 million, 5 million square yards of pavement, a typical 100-mile network in Massachusetts is about 1.5 million square yards of pavement that the community is responsible for maintaining. So these little small bits of pocket change multiplied over 1 million and 2 million square yard networks make a big difference. So we should all be paying attention to them. And then the last thing I wanted to share with you before we answer your questions, we're getting close to the end of our hour here, is some structural issues that we want to consider as we're picking rehab processes. When engineers design new pavements, they look at different layer material types, different layer thicknesses, and each of those layers has a structural coefficient per inch of thickness that you can see on this diagram. There's not an exact agreed upon answer for these structural coefficients. Different agencies use different numbers, but generally most people think that hot mix asphalt is up in the 0.40 to 0.44 range per inch of thickness. Granulars can be 0.12 to 0.15. So for the purpose of this sketch here, I took 5 inches of new asphalt on top of 12-inch granular base, and I approximated a structural number when that road was built of just under 3.88. The thing that I learned as we got into the CIR process is these materials degrade over time, not a surprise, right? The asphalt oxidizes, ravels, starts to dry out, become more crack susceptible. And as those things happen over long periods of time, say 20, 25 years, the structural coefficients of those layers drop. So for this particular example, I think we can approximate somewhere about a 40% drop in structural capacity of this road, strictly as a result of the aging and the reduction in those structural coefficients. So maybe if we didn't do any preventive maintenance to that road over that 20, 25-year period, it would look like this. So we know this is not a shallow mill and fill candidate, right? Way too far shattered for that. So let's look at 3 different rehab options and let's compare the cost of those options together with the new structural number provided. So I'm going to look at a deeper mill and fill, say 3 inches instead of just 1.5 inches. I'd like to look at full depth reclamation, say 8 inches deep with 4 inches of new hot mix on top of that. I'd like to also compare with cold in place recycling, 4 inches deep with 1.5 inches of hot mix on top of that. So going back to the roadresource.org website, another very, very helpful interactive calculator at that website is the structural calculator. And what it allows us to do is to compare options side by side, looking at these different layer thicknesses and look at both the structural number produced by different alternatives and the project cost. So here, we don't have time to get into the nitty gritty detail layer by layer, but you can see the 3-inch deep mill and fill alternative on the left came up with a total structural number of just under 3 for a project cost of about $660,000, whereas FDR 8 inches deep, and that's unstabilized FDR, with 4 inches of hot mix on top of that, came up with a much higher structural number, 3.78, so almost up as high as the new pavement was that we looked at on that last sketch, but at $160,000 more in project cost. Now let's compare the 3-inch deep mill and fill with cold in place recycling, 4 inches deep plus 1.5 inches on top of that. You can see here, again, the same numbers for the mill and fill, a structural number of about 3 and project cost of about $660, and a structural number for the CIR option of around 3.5 with a project cost of $600. So let's look at a table of the results of those comparisons. So that existing condition, the old degraded pavement had dropped to a 2.2 structural number. All 3 of these solutions provide improvement there. There's the total job cost approximately for the 3 solutions. And you can see that the CIR option that provides about a 7 or 8% lower structural number, but at about 27, 28% lower cost. So something to be considered. And then when you look at the equivalent annual cost, again, the CIR looks to be very advantageous compared to the other options. So as you're looking at fixing bad roads and all the different rehabilitation options available to you, I encourage you to look at not only absolute cost, but equivalent annual cost and structural numbers of each solution. So make sure you're getting the best value for your taxpayers. So there you go. I think we checked all 3 boxes of sustainability. I think it's a really good option for bad roads. We got a lot of bad roads. Thus far, we've worked for almost 24 clients, done almost 40 jobs, and of this list of clients, I think 10 of them have done more than one project, like Scott and Milford. So I think that's a testament to how reliable the process is and how pleased people are using the process. Here's some pictures of our completed jobs, and we mentioned earlier, if you'd like to get out and see one of our jobs, reach out to your regional manager or shoot us your name and some contact information, and we'll make sure to let you know when there's a CIR job coming up in your area. So it looks like we're right about an hour, and again, thank you all for being here. We're going to do the best we can now answering